Climate change. It's a hot topic. Literally and figuratively, we hear about melting ice caps, rising sea levels, and extreme weather events. The message is clear: humans are to blame, and the consequences are dire. But what if there's more to the story? What if the situation isn't as straightforward as some would have us believe? This isn't about denying that our climate is changing. It's about acknowledging that there are alternative viewpoints, different ways of interpreting the data, and perhaps even questioning the severity of the problem and the effectiveness of proposed solutions. Just as a doctor wouldn't prescribe medication without a full diagnosis, we shouldn't rush into drastic action without considering all sides of the climate debate. It's easy to get caught up in the fear and urgency that often surrounds climate change discussions. But it's crucial to remember that science thrives on debate, scrutiny, and the constant reevaluation of evidence. By silencing dissenting voices, we risk stifling scientific progress and potentially missing out on innovative solutions. This essay aims to shed light on some of these alternative perspectives, encouraging a more balanced and nuanced understanding of climate change. It's not about dismissing the concerns of those worried about the future of our planet. Rather, it's about fostering open dialogue, promoting critical thinking, and ultimately, making informed decisions based on evidence, not just emotion. Let's explore the other side of the story. Historical data, such as ice core samples and tree rings, reveal that our climate has always been in flux. Predictive models offer a range of potential future scenarios, each with its own set of assumptions and uncertainties. Innovation and balanced research are key to developing sustainable solutions that address the multifaceted nature of climate change. Collaborative efforts and informed policymaking can lead to effective strategies that benefit both the environment and society. Understanding the complexity of our ecosystems and their natural resilience is crucial for environmental stewardship. Let's embark on a journey of balanced research and open-minded exploration to truly comprehend the changing climate. The dominant narrative on climate change paints a bleak picture. We're told that human activity, particularly the burning of fossil fuels, is the primary driver of global warming, leading to catastrophic consequences for the planet. This narrative is often presented as undisputed fact, leaving little room for questioning or alternative interpretations. However, a growing number of scientists, researchers, and policymakers are beginning to challenge this consensus. They argue that while human activity undoubtedly plays a role in climate change, its impact may be overstated. They point to historical climate fluctuations, natural climate cycles, and the influence of solar activity as potentially significant factors that are often downplayed or ignored in mainstream discussions. These dissenting voices are not climate change deniers. They acknowledge that the Earth's climate is changing, but they question the severity and immediacy of the threat. They argue that the focus on reducing carbon emissions as the sole solution is misguided and potentially harmful, diverting resources from more pressing global issues like poverty, disease, and access to clean water. It's important to remember that science is not about consensus, it's about evidence. Just because a majority of scientists hold a particular view doesn't make it an absolute truth. Throughout history, scientific breakthroughs have often come from those who dared to challenge the status quo, to question the prevailing dogma. Climate change is no different. By encouraging open debate and allowing dissenting voices to be heard, we can foster a more robust and nuanced understanding of this complex issue. One of the primary arguments put forth by those who question the mainstream climate narrative is the role of natural climate variability. The Earth's climate has always fluctuated, long before human activity could have had any significant impact. Ice ages have come and gone, temperatures have risen and fallen, and ecosystems have adapted accordingly. Proponents of this view point to historical warming periods, such as the medieval warm period, which occurred between the 9th and 14th centuries, as evidence that the Earth's climate can change significantly without human intervention. During this period, temperatures in some regions were even higher than they are today, yet human carbon emissions were negligible compared to current levels. Another factor often cited is the influence of solar activity. The sun is the primary driver of Earth's climate, and variations in solar output, such as sunspot cycles and solar flares, can have a significant impact on global temperatures. While the link between solar activity and climate change is complex and not fully understood, some scientists believe that it plays a more significant role than is currently acknowledged. Furthermore, critics of the mainstream narrative often argue that climate models, which are used to predict future warming trends, are inherently flawed. They point to the fact that these models often struggle to accurately replicate past climate variations, suggesting that they may be overestimating the impact of human activity. The mainstream narrative on climate change typically emphasizes the role of human activity, particularly the burning of fossil fuels, as the primary driver of global warming. It argues that the increase in greenhouse gas emissions, such as carbon dioxide, is trapping heat in the atmosphere, leading to a gradual warming of the planet and a range of negative consequences, including rising sea levels, more frequent and severe weather events, and disruptions to ecosystems. This narrative often portrays the situation as dire and urgent, calling for immediate and drastic action to reduce carbon emissions. It advocates for a rapid transition to renewable energy sources, increased energy efficiency, and significant changes to our lifestyles and consumption patterns. Alternative views, while acknowledging that human activity plays a role, often present a more nuanced perspective. They emphasize the role of natural climate variability, pointing to historical temperature fluctuations and the influence of solar activity as evidence that the Earth's climate is constantly changing, with or without human intervention. These views often question the accuracy and reliability of climate models, arguing that they may be overestimating the impact of human activity and failing to adequately account for natural climate variations. They also tend to be more skeptical about the severity and immediacy of the threat posed by climate change, suggesting that the focus on reducing carbon emissions as the sole solution is misguided and potentially harmful to economic growth and societal well-being. Section 5. The Sun's influence, a force to be reckoned with. The Sun, the star at the heart of our solar system, bathes our planet in light and warmth, making life as we know it possible. It is the primary driver of Earth's climate, yet its role in recent warming trends remains a topic of debate. While mainstream climate science acknowledges the Sun's influence, it often downplays its significance compared to human-induced greenhouse gas emissions. However, some scientists argue that variations in solar activity play a more substantial role in climate change than is currently recognized. They point to historical correlations between solar cycles and Earth's temperature, suggesting a strong link between the two. For instance, the Little Ice Age, a period of cooler temperatures that spanned from the 14th to the 19th centuries, coincided with a period of reduced solar activity known as the Maunder minimum. Solar activity is not constant. It fluctuates in cycles, the most well-known being the 11-year sunspot cycle. Sunspots are temporary dark spots on the sun's surface that mark regions of intense magnetic activity. During periods of high sunspot activity, the sun emits more energy, including ultraviolet radiation, which can impact Earth's atmosphere and climate. While the exact mechanisms by which solar activity influences Earth's climate are complex and not fully understood, some scientists believe it could involve changes in cloud formation, atmospheric circulation patterns, and even the amount of cosmic rays reaching Earth. These potential influences, they argue, warrant further investigation and should not be dismissed as insignificant. Section 6. Natural cycles. The Earth's climate story through the ages. Our planet's climate is a dynamic and ever-changing system, shaped by a complex interplay of natural forces. Throughout Earth's 4.5 billion-year history, the climate has undergone dramatic transformations, from scorching hot periods to frigid ice ages. These fluctuations are a testament to the powerful natural cycles that govern our planet's climate system. One such cycle is the Milankovitch cycles, named after Serbian geophysicist Milutin Milankovic. These cycles describe the collective effects of changes in Earth's orbital parameters, such as its eccentricity, the shape of its orbit around the Sun, obliquity, the tilt of its axis, and precession, the wobble of its axis. These variations, occurring over tens of thousands of years, affect the amount and distribution of solar radiation reaching Earth, influencing long-term climate patterns. Another significant factor is volcanic activity. Volcanic eruptions can release massive amounts of greenhouse gases, such as carbon dioxide, into the atmosphere, contributing to warming. However, they can also eject large quantities of aerosols, tiny particles that reflect sunlight back into space, resulting in a cooling effect. The net impact of volcanic eruptions on climate depends on the balance between these warming and cooling effects. Furthermore, Natural variations in ocean currents, such as El Niño and La Niña events in the Pacific Ocean, can have a significant impact on global temperatures and weather patterns. These cyclical events involve changes in ocean surface temperatures and atmospheric pressure, leading to shifts in precipitation patterns, wind systems, and even the frequency and intensity of extreme weather events. Section 7. The data debate. Are we seeing the whole picture? The debate surrounding climate change often centers around the interpretation of data, particularly temperature records. Mainstream climate science relies heavily on surface temperature measurements, which show a clear warming trend over the past century. However, some critics argue that these measurements are flawed and may be exaggerating the extent of warming. One criticism is that the location of weather stations can influence temperature readings. Urban areas, with their concrete surfaces and human activity, tend to be warmer than rural areas, a phenomenon known as the urban heat island effect. Critics argue that the expansion of urban areas over time may be skewing temperature records upward, making the warming trend appear more dramatic than it actually is. Another concern is the potential for data manipulation or adjustments to historical temperature records. Critics point to instances where adjustments have been made to past temperature data, sometimes without clear justification, which they believe may be introducing biases and uncertainties into the data. Furthermore, some argue that surface temperature measurements alone do not provide a complete picture of Earth's climate system. They emphasize the importance of considering other metrics, such as ocean heat content, sea level rise, and ice melt, to gain a more comprehensive understanding of climate change. The debate over data interpretation highlights the importance of transparency, rigor, and independent verification in climate science. It underscores the need for open access to raw data, clear documentation of any adjustments made to the data, and robust statistical analyses to ensure the accuracy and reliability of climate change assessments. Section 8. The importance of open dialogue, embracing diverse perspectives. The climate change debate, like any complex scientific issue, benefits from open dialogue and the consideration of diverse perspectives. Attempting to silence dissenting voices or dismiss alternative viewpoints as denial is not only counterproductive, but also detrimental to scientific progress. Science thrives on skepticism, debate, and the constant testing of hypotheses. It is through rigorous scrutiny, challenging assumptions, and exploring alternative explanations that we advance our understanding of the natural world. Climate change is no exception. Embracing open dialogue means creating a space where scientists and researchers with differing viewpoints can engage in respectful and constructive debate. It means encouraging critical thinking, questioning assumptions, and being open to the possibility that our current understanding of climate change may be incomplete or even flawed in some respects. Furthermore, open dialogue requires acknowledging the inherent uncertainties surrounding climate science. Climate models, while valuable tools, are not perfect representations of reality and come with limitations and uncertainties. Acknowledging these uncertainties does not diminish the importance of addressing climate change. Rather, it allows for a more nuanced and realistic assessment of the risks and potential solutions. Section 9. Seeking solutions, a call for balanced research and innovation. While the debate over the causes and consequences of climate change continues, the need to find practical and effective solutions remains paramount. This requires a balanced approach that considers both the potential risks of climate change and the economic and societal costs of mitigation measures. Rather than focusing solely on reducing carbon emissions, which can be economically disruptive and disproportionately impact developing nations, we should also invest in adaptation strategies. This includes developing drought-resistant crops, building seawalls to protect coastal communities, and improving early warning systems for extreme weather events. Furthermore, we need to foster innovation in areas such as carbon capture and storage, geoengineering technologies, and next-generation nuclear power, which could provide cleaner and more sustainable energy solutions. By investing in research and development, we can expand our toolkit for addressing climate change and find solutions that are both effective and economically viable. Ultimately, addressing climate change requires a global effort, but one that is grounded in sound science, pragmatic solutions, and a recognition of the diverse circumstances and priorities of nations around the world. By embracing open dialogue, fostering innovation, and working together, we can navigate the challenges of a changing climate while ensuring a prosperous and sustainable future for all.